step on either of their toes. So you step away all over my toes. 5 to 10 minutes. You ready? Set. Go.
Um,
Just kidding. I'm not going to.
so, how do I turn this thing on? Is it on? Is it on? I don't know. That'd be the first step.
Yeah, there's a light there. There you go.
Okay, I guess it's on. Okay. So in chapter 4, the Chadmeister discussed 3 different ways that he argues for God's existence using natural laws and things related to science. One of his arguments is fine-tuning of the world. Now, he uses 5 different examples of natural laws that everybody pretty much agrees with, that they are relevant and they actually work. This right here is the formula for gravity. I have no idea what any of those mean, but I know that that's the formula. And G here, also this represents the gravitational whatever, and it equals such and such, such and such. Now, the fact that this is so specific that this number has to equal this in order to make gravity work is his argument that there has to be some fine-tuning within nature. If G equaled anywhere other than 6.6 times 10 to the negative 11th, if it equaled anything else, gravity would not work. Gravity itself, like just dropping a pen, they'd probably just start floating around if it was anywhere other than this. Now the argument is that there's possibly just a chance that it worked out this way. That's the argument. It's possible that when the Big Bang happened, that this just happened to work. But the fact that all 5 of these and more also follow the same pattern where if one thing was changed slightly, that they would not work, shows that there must be some fine-tuning within these things. We don't argue that they don't work, because they do. But the fact is that they're so specific that there needs to be an intelligent mind behind creating these things. He also talks about irreducible complexity and uses a mousetrap analogy. For complex organisms, everything that's involved in it needs to work together and has to already be there in order to be functional. Using a mousetrap, you have a platform, a spring, a catch, and a bar to hold it down. If any of those pieces were missing, the mousetrap wouldn't work. It wouldn't function normally. So without, he uses the flagella argument. There's like a tail on this thing, and there's got like 40 different components to it. And if one of those is missing, then the system just falls apart. Now the argument is that over time, through evolution, and there needs to be some fine-tuning on what evolution really means, that progressively you come from a platform, you get the spring, then you get the catch, and then you get the bar. And all those have different functions. You could use the hook as like a fishing hook. You could use the platform as like a doorstop. They had different functions if you so chose. But the argument would be for evolution, which type of evolution are we talking about, micro or macro? Micro involves the change of different particles so that way a person or an animal or some sort of being can adapt to the situation. Macro involves complete change over to a new organism, which is what generally you would think of when you think of evolution, where this turned into this and then this turned into that. Not that it kind of changed in order to adapt to its situation, but that it progressively changed into something else. So that would be his argument, that with irreducible complexity, we're dealing with macroevolution. Or they'd try to argue against it with microevolution. So without all those pieces working together, it just would not function.
How'd you feel about the chapter?
I felt like it was a great chapter, and I might not be explaining as well as he does, but I mean, it really opened my eyes to what it is. I'll have to go back over it to really pour into it, but I think he presents very good arguments and presents the other side very well too.
Was it easy to understand, or was it difficult to understand?
Oh, he presented in a way that was pretty easy to understand.
Would you recommend it to anybody else? Like, say you're talking to an atheist friend or something, you're like, hey, read this.
Yeah.
Do you think you would recommend it?
I think I would. I think it's easy to understand, and it presents a very logical argument against their side.
What about other Christians? Would you recommend it to other Christians
I think
who are looking to strengthen their faith?
I think that this would definitely help, especially when presented in a specific situation where you had to know something along these lines, where somebody's challenging their faith, and that way they'd have an argument to back it up. So
Anything else?
that's about it. There's some other stuff, but that's what I grasped from the whole thing for the most part.
Cool. Thanks. Josiah, can you share with us right now? Yeah. Sure. Because I'm not exactly following the book's exact order of things. Because I developed my lectures before I discovered the book. So I don't want to step on your toes. I'd rather you go before me.
Yeah, I can do that.
And you just have to clip on the mic so that the camera can pick you up. And so that you look official and authoritative. Good job.
I do have a question. Are we expecting, is any of this stuff going to be on the quiz?
Just the stuff that I
Just,
communicate. Some of that actually will be on the quiz, but I will reiterate it again.
All right, so how this works are there two basic there's two basic ways of looking at the universe.
What chapter are you doing? 5?
Yeah, starts on page 91 and then the building belief book. Obviously, as Christians, we like to look at it as in the beginning God created the heavens and the earth. And that's Genesis 1:1. That's right at the beginning of our book. And now exactly what that means can be interpreted in different forms. But the fact that the universe was created at all is what we're going to be arguing. Most people go around in their day-to-day lives oblivious to the fact of things like gravity, things like atomic structures, the fact that the light is getting here in some way and was caused by some source. We usually don't think about these things. But old philosophers, people much smarter than us and more willing to contemplate, have thought about things just like this. And it boils down to the cosmological argument. Where did the world come from? Where did the universe come from? And there's two different ways of looking at it. There's a contingent form. There's a contingent argument, which means that the world did come from something and that it is necessary for that something to be there in order for it to exist. And then there's the necessary argument. 2 S's and 2 C's? Yes. Okay. There's the necessary argument. Oh my gosh. Anyway, it's fine. And anyway, necessary argument. The idea is, I'm a terrible speller, but the idea is that there is no cause. The universe is sufficient within itself. And that is something that we would not argue. Now, there's this debate that sprung off the cosmological argument called the Kalam. I'm not sure exactly how it's pronounced. But if you turn to page 92, instead of drawing it up on the board, you can just look at it for yourself. And it's that diagram in the bottom left-hand corner on page 92. It goes, the universe is at the top, and then the question is, did it begin or did it not begin? And then if it did not begin, then the rest of this argument is invalid, and it just stops there. But if it did begin, then we have to ask, is it caused or is it not caused? And if it's not caused, the argument ends there. We continue on with our day. But if it is caused, we have to argue that whether it is personal or impersonal. And so this is how the Kalam argument kind of breaks down into these three logical statements, which is on the top of page 93 if you would like to look at them. It says, whether begins to exist must have a cause. So if something begins to exist, it must have a cause. And the next logical statement is the universe began to exist, and we'll have to go on and prove that in a minute. And then if those two things are true, therefore the universe must have a cause. If what begins must have a cause, if the universe began, therefore the universe must have a cause. And we have to look at how this was caused. Something that causes something with time, space, or matter must in itself be timeless, spaceless, and materialist in order to cause those things. Has to be able to create physical energy, be able to be outside of time, space, and matter in order to be able to create those things. And in this three logical steps, those three statements, the one before it must be true in order for the second one to be logically true. So we have to prove those one at a time. There's this second law of thermodynamics. And this is a theory that people like to use in order to help prove that the universe began. And it goes along the lines, it's called entropy. And what this means is that everything will eventually come to an equilibrium in the universe. You take the analogy they use in the book is you take a hot cup of coffee, it's not sitting on a table, you walk in the room, you're wondering how long it's been there. You go up and you take a sip and it's hot. Now you wouldn't assume that it's been there for months. That's because if it had been there for months, it would come to an equilibrium with the room and be at the same temperature. But it's not, it's hot, which means that it was fresh. Same thing with the universe. Everything is hot, everything is changing. And if the universe had been here forever, we'd have a state of entropy. Everything would be the same, nothing would change. Obviously that's not true. We have Antarctica and the sun. Those are two vastly different environments. Not all the same temperature. So that's the argument for the universe began. Now there are some other theories that we really don't have to talk about that try fighting this. Just to mention them a little bit is the cycles theory, where there's a system of expansion, or a cycle of expansions and contractions where the universe expands to a certain point where gravity pulls it back in, and then it comes back to a certain point and explodes and goes back in and out. That is one way of doing it, but it is just bad science. People like Stephen Hawking have fought against that. They say that it doesn't hold water in the views of science. And then there's the continuous creation theory, that the universe is ever expanding and new matter is being formed, but nothing is changing. And obviously that doesn't hold scientific water either, because science observes things changing. And there's multi-dimensional theories, but those are proto-scientific, and those are outside. It's like metaphysics or theoretical physics. They just are theories outside of scientific basis that have scientific-like ideas. And so those really can't be taken into consideration at this time with our understanding of them. Now, the largest theory is the Big Bang theory, but it too argues that everything has a cause. So we are in the same boat as the Big Bang theory. Everything began and everything came from one source. So back to proving the second point of the Kalam theory, which is that the universe began to exist. It goes back to the entropy, everything's hot, everything changes, therefore it must have had a beginning because it hasn't come to a state of equilibrium. And there's a lot of big words and a lot of big ideas of what infinity is that are just really hard to wrap your mind around. There's potential infinity, which means that something is potentially infinite. Like if you started counting from 1 to infinity, as you add another number, it gets ever larger into infinity. And then there's absolute infinity, which is the idea that it is infinite within itself, and it's not adding new members in order to become infinite. Now, if the universe was absolutely infinite, it would not have a beginning. And since we concluded that it did have a beginning, it cannot be necessarily existent on its own. And that points back to it being contingent, which means it depends on something. It can be potentially infinite, though, where if we start at one point, we add a series of historical events and we get to a point where we arrive to now, and the future goes on forever. Now it comes back to, so we've proven that the universe had a beginning and that it relies on something, and we must now prove that it is God that did all this. The exact attributes that you need in order to create something that has time, space, and matter line up with God. They are the same attributes we point towards as God. He is infinite. He is outside of time. He's outside of space. And those are the things that we need in order to create a universe with time and space.
How'd you feel about the chapter?
Oh, well, it was a very deep chapter.
Yeah.
A lot of science and a lot of theory that went back a really long time. And so it's kind of hard to wrap your head around, but these are things I like learning about anyway. So I was kind of familiar with the material beforehand. So I think it was an overall very compelling chapter.
You would recommend it to people, but probably only certain people that would be able to handle that kind of sciencey stuff.
I would only recommend it to people who are searching for answers particular to that.
Yeah.
Or who are arguing against those certain arguments. Like, it's not necessary to bring those things into a topic with like an 8th grader or, somebody who doesn't really care, because it's just going to make them zone out, which I'm sure many of you did while I was talking. But it's just going to make them zone out and not pay attention because, you can't really wrap your head around things like that sometimes.
All right, thank you.
Yep.
Good job. Use your mic.
But I like it. Makes me authoritative.
I'll do the cameras. You whisper to Jacob.
Hey, Jacob, I'm about to fall asleep on the class.
And Miss Sean got it.
Thank you. All right, so I have a lot to say about this topic. I first got interested in the arguments for God's existence. I don't even know, but it was a long time ago, and I've been studying on it for a long time. The first time I acquired any kind of systematic understanding of this was in a philosophy of science class I took at when I was studying to become an engineer at one point in my life. And it was really cool because here I am in basically an atheist institution, and my professor is teaching me the 3 main philosophical arguments for God's existence. I'm like, sweet, I got myself a good teacher here. And he did. He went through and he addressed these different arguments and proved God's existence. And I'm thinking to myself, this guy, what is he, like a closet Christian, like hiding out here behind enemy lines or what? But I don't even remember the guy's name, but I always appreciated, his courage to do that in that class, in that context among those people. But here are, let me just plug in here. Here are the main 3 categories. Let's see, does that show up? Yeah. Here are the 3 main kinds of arguments for God's existence. You have the ontological argument for God's existence. That's based on reason alone. So that's basically looking at God's existence by itself, not necessarily looking at the universe to prove his existence, but considering the question of his existence by itself. So you just need reason for that. You don't need anything else. Then you have the cosmological argument, which is based on causality, and that's the one you were doing, right? Kalam cosmological. So that's the idea that you trace back a chain of cause and effect to the beginning cause. And then the third kind of argument for God's existence is based on order and design. Now, there are many arguments. I'm going to go through like 8 or so with you. But they can all be broken into one of these 3 main categories, whether the ontological, the cosmological, or teleological. Most of our arguments for God's existence are teleological, which we also would call like intelligent design arguments.
So
How do you say it? Teleological?
I say teleological. I think teleological would be just fine too. But it's relating to design or purpose, especially in nature. That's teleological. It's from the Greek word. What is it? You weren't done? All right, there you go. Based on order and design, yeah. So teleological is something that's relating to design or purpose. It's related to the Greek word telos, which is the word meaning the end of something, which can mean the physical end of something or its purpose. Hence, telephone is like sounds that make it to the end of a wire. Or television, telescope, it's also telewords, you know. But it's always telos word of the end or purpose or design of something. So teleological is dealing with purpose and design. I got to get in my notes to where I'm supposed to be here. There we go. I don't want to just wing it. Okay. So the standard teleological argument goes as follows. 1. The universe evidences order and design. 2, a design requires a designer. 3, a designer of the universe exists. So the first two statements there are premises, and the third is the conclusion that follows from those premises. It's a very common sense argument. You know, I'm kind of systematizing it and giving you the official way of talking about it, but it's just as simple as this. How do I know that a painter exists of this right here? I have the painting. Is this even? Yeah, it is a painting. So if there's a painting, well, this is a picture of a painting, but originally there was a painting, right? If there is a painting, that's proof that there's a painter. Simple, right? If there's a building, there must be one or more builders out there who existed at some point if there's a building at this point, right? It's completely logical way of approaching things. What about a tree? What's more complicated, that painting or a tree?
The tree.
Trees can reproduce, trees can provide shade, trees can produce oxygen, you know, what's that? Grow, right? Trees can turn into paper and we could write on them. I mean, trees are magnificently complex. I mean, you could stab a tree with a knife and it would like I hit a tree with my car one time, and then I went back like the next year to observe how the tree was doing, and I couldn't find which tree it was. There was like like 5 trees there. I'm like, which one was it? Because it just kind of sapped over itself and healed, and my car didn't really make that much of a dent. It sure did total my car though. So trees are pretty awesome, and yet when we look at a tree, because of the way our culture is and it's so secular, we don't say to ourselves, a tree maker exists. But yet a tree is more complicated than a painting or this room we're sitting in. And we know that there was some designer who said, all right, we're going to put the lights right here, we're going to put the ceiling panels there, we're going to put this kind of carpet, we're going to pick this color. You know, there were designers involved, right?
Yeah, in the chapter I read, there was an argument that said if there were like 2 guys walking in the woods and they saw this giant round ball that was out of nowhere, they'd never seen it before, and he's like, theist and atheist, theist has atheist, do you think this just came out of nowhere? And the atheist would be like, of course not, someone made it. And it happens a couple more times. He's like, what about the universe, a giant round ball that no one's ever seen before? I think it just came out of nowhere. He's like, no, it's always been here.
Here's a little video that I thought was pretty funny. It's called The Atheist's Worst Nightmare.
Now, if you study a well-made banana, you'll find on the far side there are 3 ridges. On the close side, 2 ridges. If you get your hand ready to grip a banana, you'll find on the far side There are 3 grooves on the close side, 2 grooves. The banana and the hand are perfectly made one for the other. You'll find the maker of the banana, Almighty God, has made it with a non-slip surface. It has outward indicators of inward contents. Green, too early; yellow, just right; black, too late. Now if you go to the top of the banana, you'll find, as with the soda can makers, they placed a tab at the top. So God has placed a tab at the top. When you pull the tab, the contents don't squirt in your face. You'll find the wrapper, which is biodegradable, has perforations. Notice how gracefully it sits over the human hand. Notice it has a point at the top for ease of entry. It's just the right shape for the human mouth. It's chewy, easy to digest, and it's even curved toward the face to make the whole process so much easier. Seriously, Kurt, the whole of creation testifies to the genius of God's creative hand.
Okay, so
That's so awesome.
that's the teleological argument. You're looking at something, you're saying, look, the banana sure seems designed. It sure seems like somebody put thought into that. I mean, if you look at, a can, can I get or here's one right here, a Coke can. We're in Atlanta. It's more true to our context. What are some design features that the banana has that this Coke can doesn't have? The non-slip surface. Like, as soon as this gets wet, it's just like you can easily drop it. If you drop it, you have to wait a while before you open it, right? Because otherwise it'll spray all over the place. This stuff will kill you if you drink too much of it, whereas the banana is actually good for you. And it can help with cramps if you're running or exercising and your legs are cramping up. You eat a banana and you're like, oh yeah, let's go. So I mean, it's just but nobody would ever say this just magically appeared, right? Obviously somebody designed this, and yet a banana is better designed than the Coke can. So there's an inference to a designer there, right? All right, so I have 2 scriptures that relate to this. One is Romans chapter 1, verses 18 to 20, and the other is Psalm 19, 1 through 4. I'll show you that again in just a second. But you definitely want to write these down because, like I said to you before, anytime I do find scriptures that are relevant, I definitely want to bring them up because this class doesn't actually involve the Bible much, and I'm a big fan of the Bible. So, Dan, could you read this for us?
Yeah. For the wrath of God is revealed from heaven against all ungodliness and unrighteousness of men who suppress the truth in unrighteousness, because that which is known about God is evident within them. For God made it evident to them. For since the creation of the world, his invisible attributes, his eternal power and divine nature have been clearly seen, being understood through what has been made, so that they are without excuse.
Right. So since the idea that there is something evident about God, but especially this here, for since the creation of the world, God's invisible attributes are clearly seen through what has been made. I mean, people can look at the universe and they should make the inference to a God who made the universe. That's what Romans 1 is basically making the case. Paul's making the case that people basically know that God exists just by looking at creation itself. Psalm 19, 1 through 4 is this beautiful poetic way of saying a very similar thing. Talon.
The heavens are telling of the glory of God, and their expanse is declaring the work of his hands. Day to day pours forth speech, and night to night reveals knowledge. There is no speech, nor are there words. Their voice is not heard. Their line has gone out through all the earth, and their utterances to the end of the world. In them he has placed a tent for the sun.
Oh, okay, there we are. So the heavens are telling of the glory of God. Do you know what branch of science has the highest concentration of theists, people that believe in God? It's the people that study the stars, people that study, the grandeur of the cosmos. The heavens are telling the glory of God. I mean, it is just so impressive when you study the universe and how it works. And, if you take something as simple as gravity or the electromagnetic force or nuclear forces, like the strong or weak nuclear forces, any one of those 4 forces you study, you're like, wow, this thing is just so amazingly designed. And if you go far enough with physics, that you get to start studying relativity theory and what Einstein started to discover in the early 20th century, it'll just blow your mind how the universe works and how it's put together. Let alone quantum theory and how tiny little things work at a microscopic scale. I mean, it's really hard not to say this thing is amazingly put together. But no, we can't say that. We can't say that because we know it just came from nowhere, right? So that's kind of where we're at with that. There are some advantages to the teleological argument that other arguments don't have. One of the advantages is that it's very easy to prove because it's inexperience. You can talk about a banana or a painting. Those are things that are in people's experience. They know about. You don't necessarily have to jump to talk about the gravitational constant like Talon did, which we appreciate that Talon did that. I'm going to come back to that later. But the teleological argument is right in people's experience, and the argument uses well-established scientific facts to prove the existence of God. The teleological argument tends to be very science-heavy. If you're not a science person, you're not going to enjoy this lecture. The next one you'll probably like, though. Okay, it's more philosophical than scientific. If you are drawn to science or you're talking to somebody that's a science person, teleological argument is probably where you want to spend your time. And true science, I believe, will always lead to God. After all, science is a study of the creation, and thus it's indirectly a study of the Creator. And so I'm not anti-science at all. My first degree was a bachelor's in science. So I love science. I think science is cool. And science is really studying creation. So how can it not help but extol and lift up God? Okay. Just have to kind of see what I want to do here. All right, we're going to skip all that. So one of the things that I want to make a distinction between is operational science and historical science. And this is a distinction made in the Answers book put out by the Answers in Genesis people. And I think they make a really good point here, because when you look at operational science, that's the kind of science that does experiments on things to figure out what is the case and what is not the case. And that's the kind of science that ends up giving us advances in medicine and discovery of DNA and a lot of the transportation and communication advances that we have. And then you have historical science. And you see there's a guy who's just sort of like holding his thumb up to a bunch of bones and imagining what they actually look like if they had spots and how they attacked each other. And it's just, I don't know, I just want to make a distinction between these two realms of science. One, I consider legitimate science, where they are actually testing things, coming up with hypotheses, and figuring out if those are false or not. And the other one is just like telling stories to fill in the details. And I feel like when it's story time, we're not doing science anymore, honestly. And that's a lot of what ends up happening, sadly, in our time.
Do you kind of mean going back and like finding gaps in what they think happened evolutionarily and things like that? Is that what you mean by historical science?
Yeah, I think basically what we're saying is, they're both going to have the same degree. They're both going to wear the white coat. They're both going to be called scientists. But one's doing actual science, and the other one is just guessing at what he thinks might have happened. And I don't consider that science. I consider that guessing to think what might have happened. It's history. It's not like it's an illegitimate enterprise, but I don't think it deserves the label of science, even if we complicate it with all sorts of technical jargon. That doesn't make it science either. That just makes it complicated with technical jargon, which you can do to Dr. Seuss books if you want. It doesn't make it science either. All right, so I want to talk to you about the watchmaker argument. This is the most classic form of the teleological argument, pioneered by a guy named William Paley a few hundred years ago. And this is what William Paley said. Jesse.
In crossing a
Heath.
Suppose I pitched my foot against a stone.
It's like Old English, sorry, but it is what it is.
and were asked how the stone came to be there, I might possibly answer that, for anything I knew to the contrary, it lain there forever, nor would it perhaps be very easy to show the absurdity of this answer. But suppose I had found a watch upon the ground, and it should be inquired how the watch happened to be there in that place. I should hardly think of the answer, which I had before given, that for anything I knew, the watch might have always been there.
All right, so if you see a rock, you might be tempted to say, this rock's just always been here. But if you see a watch on the ground, nobody's going to say this watch has always been there, right? Why? What's the difference between a rock and a watch? Watches are more complex. Okay. What else? What were you going to say? A rock is part of nature. Anything else? All right, next slide here.
The watch must have had a maker, that there must have existed at some time in some place or other an
Artificer.
artificer or artificers
That's somebody that
Who-
makes something.
who formed it from the purpose which we find it. Actually, to answer, who comprehended its construction and designed its use. Every indication of
Contrivance.
contrivance, every manifestation, that word, of design which existed in the watch exists in the works of nature, with the difference on the side of nature of being greater or more, and that in a degree which exceeds all computation.
Whew, you got a tough one there, huh?
And I don't have my glasses.
Well, you're done now, so just relax. So the watch, when you see the watch, you immediately make a design inference. In other words, you immediately say, somebody made this object. You don't make that inference, though, when you see trees or plants or dogs, right? You just say, oh, dogs, they just came from other dogs, and they came from other dogs, and maybe they came from a banana way back. What? You know, so like, why is it that when we see something complicated like a watch, we make a design inference, but we see something way more complicated like a dog, we're just like, I don't know, somehow it got here. You know, it's a double standard. And so what William Paley's saying is, in nature, the living things that are around us are more complex than something as simple as a watch. And so they should themselves point us to a maker. I'm going to give you the example of the hummingbird, okay? And so what I want to do in the rest of this lecture is cruise through 4 arguments for God's existence. They're all teleological, okay? The first is the hummingbird. I want to just describe the hummingbird to you, and I think once I describe it to you, you're going to be like, this thing is awesome. There's no way it just sort of like popped into existence. You know, it had to have been designed. And then I want to use a cell, just a normal living cell, okay? And that's number 2. Number 3 is DNA. And then number 4 is fine-tuning, which Talon had already described a little bit. So I'm just going to kind of review some of the things he said. But each of these is an argument for God based on design or some sort of teleological reasoning. So the hummingbird, right? Jacob, could you read for us? This is from a book called In 6 Days by John F. Ashton.
For controlled, heavier than air flight, there are four fundamental requirements: a correct wing shape to give a lower air pressure on the upper surface, a large enough wing area to support the weight, some means of propulsion or gliding, and extra surfaces or a means of altering the main surfaces in order to change direction and speed. Flight occurs in many branches of the living world: birds, insects, flies, bees, wasps, butterflies, moths, mammals, bats, reptiles, the extinct.
Pterodactyls.
Yep, that's the one. Each class of creature is anatomically different, with no connection made even by the most ardent evolutionist. A bird's wings are made of feathers. A feather is a marvel of lightweight engineering. one stage further, since the ridges allow slide and joint, and there is thus an ingenious mechanism for keeping the surface flexible and yet intact.
Have you ever thought about a feather before? Have you ever noticed that when you hold a feather, you can go one way and it's okay, and if you go the other way, it frays all apart, and then it's hard to put it back together again, right? And the thing about feathers is that, like you said, they're very light. You know, like if you drop a feather, it just sort of floats down, right? But it's very wind resistant, which makes it so helpful for a bird to use a bunch of them to form a wing that can then flap and cause significant air resistance so that they could fly. It's a very well-designed system. Let's keep going here, Josiah.
That is not all. Even if one had the feather, the delicate lattice structure would soon become frayed, unless there was also an oil to lubricate the sliding joints by the hooked and ridged barbules. Most of us realize that once the barbs of the feather have been separated, it is difficult to make them come back together. The feather becomes easily frayed in the absence of oil, which a bird provides from its preening gland at the base of its spine. Some of this oil is put on its back, or put on its beak, and spread throughout the feathers, which for a water bird also gives waterproofing of the surface. Thus, water slides off the duck's back. Without the oil, feathers are useless. So even if a supposed land-dwelling dinosaur got as far as wafting a wing, it would be no use after a few hours. As one might expect, however, the story does not end there either. For a bird can fly only because it is also an exceedingly light bone structure, which is achieved by the bones being hollow. Many birds maintain skeleton strength by cross members within the hollow bones, such as arrangement began to be used in the middle of the century for aircraft wings, and is termed with Warren's truss arrangement.
Large birds, such as an eagle or vulture, would simply break in pieces in midair if there were some supposed halfway stage in their skeletal development where they had not yet developed such cross members in their bones. So we looked at the feather, pretty impressively designed, right? The feather has these barbs that come off of it, right? And in between it, it has barbules. One side is a ridge, the other side is a hook, and somehow these things connect to each other but allow motion, and then those are oiled from the preening gland of the bird. In addition to that, birds' skeletal structure is highly specialized for flight. Your bones are very heavy. That's probably why it's hard to, like when humans were first starting to make attempts at flight, they would just strap on these like huge wings and flap around, and like probably a bunch of people died that way. I don't know, but we're heavy, and birds are not heavy because they have these hollow bones. It's another part of the structure. So we've described the oil required, we've described the feather, we've described the bones, but there's still more. They breathe differently. Have you ever stuck your head out the window when you're driving really fast? Or somebody else is driving really fast? And it's hard to breathe? Do you know why?
It's too much air.
Yeah, the air's like pushing on your face, right? So what if you're a bird and you're flying at like 50 miles an hour? Like, you just like stop breathing, or birds are small. They don't have like big, huge diaphragms like we do that can like push all this air up, right? So they breathe differently than us. The respiratory system of a bird enables oxygen to be fed straight into air sacs, which are connected directly to the heart, lungs, and stomach, bypassing the normal mammalian requirement to breathe out carbon dioxide first before the next intake of oxygen. Human beings breathe about 12 times a minute, unless they're in apologetics, and it's like 15 times a minute because they're so excited. Whereas small birds can breathe up to about 250 times a minute. Whew. Thus, there's a perfect system for the high metabolic rate of birds, which use up energy very quickly. In fast-forward flight particularly, birds could not sustain exhaling against the oncoming airstream. Note also that birds are warm-blooded, which presents a vast biological hurdle for those who maintain a reptile ancestry for birds. All right, so now we talked about breathing a little bit. They have this highly adapted method of breathing that is completely different than what we have. Now we have to talk about the wing flapping motion. This requires a bird to have strong wing muscles with a forward-facing elbow joint to enable the foreshortening of the wing used much in the upward stroke of most species and in the dive birds of prey. So you have to have good wing muscles to do that. And the versatility of the swivel joint at the base of the wing, coupled with the elbow joint on the wing itself and the smooth feather structure overlaying all, leads to great flexibility and aerodynamics of the wing. Lift and drag can be balanced with instant movements, which in aircraft still require comparatively cumbersome changes of flap and ailerons. And then he talks about, well, what about, so you have to have, wing muscles. And he's like, yeah, but what about the tail? You need a tail, or else you're just like flying all over the place, right? So you need a tail with its own way to control flight and its own muscles, right? And then you have to plug all this stuff into the onboard computer called the brain of the bird so that it controls it properly, right? And we still haven't even touched the actual hummingbird, all right? Let me just skip ahead to that part. Whew. Copied a lot here, didn't I?
Like amazing.
Oh, wait till you hear the hummingbird. It's going to blow your mind, unless you've already researched this. But one of the most delightful demonstrations of all these principles coming together involves the hummingbird. These small birds have the ability to beat their wings at up to 80 beats per second. 1001, 80 beats. 1002, 160. 1002, 240, right? 80 beats per second. That's some serious wing muscles, right? And as well known, can hover, fly backwards, forwards, and sideways with ease. Speeds of 50 miles an hour are commonplace for these flying marvels. Fuel must be replenished very quickly because of the great turnover in energy. Consequently, the bird must feed on a food which can be broken down quickly into energy. What's that? Sugar. Oh yeah. All this is achieved by feeding on the nectar of flowers, which requires the ability to hover and a thin, long beak to get into the flower. I'm not going to attempt to say that word. The bird also has a special tongue with 2 furrows, enabling the nectar to be stored on it. The long tongue goes in and out of the bill at an unbelievable rate of 13 times per second. Imagine that, you stick your tongue out and in 13 times, in 1 second. I think Jesse got 3 times in a second there. He was cruising too. When retracted, it is curled up at the back of the head. One can envisage the odd scenario of the supposedly half-evolved hummingbird either with the ability to hover and a sparrow beak, unable to feed, or the long beak but no ability to hover, which would mean flying into the flower with no ability to stop. All the requirements must be there to begin with. In order to have flight, you have to have all this stuff. In order to have a hummingbird level of just elegant flight, come on, hovering, that's awesome, right? They can hover, they can be just chilling and then just go sideways a little bit, right? Or they can go backwards a little bit. It's incredible what they're able to do. 50 miles an hour, you go 50 miles an hour without a car. I'd like to see you try.
Give me a bag of sugar.
Even with a bag of sugar. The extreme maneuverability of the hummingbirds is due to their having the ability to swivel the wing through a much greater angle than other birds. And so they create a power stroke up and down. It is not scientific to argue, on the one hand, for the obvious design of a Boeing 747, and then rule design out of court when considering the far more versatile flight of an eagle, falcon, or the remarkable hummingbird. That's the design inference. We're saying, look, hummingbirds are better designed for flying than, human-designed aircraft, because human-designed aircraft struggle to do any number of these small maneuvers, fine-tuned maneuvers that the hummingbird can do. We've just figured out how to make little drones that can hover. You know what I mean? And if you see a drone hovering around out on the porch there, nobody's I wonder if a skateboard and a remote control car somehow got together and randomly produced this object without any intelligence behind it. Nobody says that. They're wow, what are they designing next? Right? Isn't that what we say? So when you see design, it bespeaks or it points to a designer. So that's argument number 1 is the hummingbird. Argument number 2 is cell complexity. And so I want you to consider a human cell. Here's a picture of a human cell. Huh?
Why is it hairy?
Why isn't it hairy?
Everything is weird with biology and chemistry. They go together. Literally.
Formerly, this is Howard Perth in his book Blind Faith. Formerly, it was thought that a cell was composed of a nucleus and a few other parts in a sea of cytoplasms with large spaces in the cell unoccupied. Now it is known that a cell literally swarms, that it is packed full of important functioning units necessary to the life of the cell and the body containing it. The theory of evolution assumes life developed from a simple cell, but science today demonstrates there's no such thing as a simple cell. Even the simplest organism known to man, just like the basic bacterium, still has this incredibly complex set of organelles within it that are doing all kinds of different things, from generating energy to metabolizing to copying DNA and RNA and letting stuff in and out of the cell. I mean, the cell, there is no such thing as a simple cell. And, you know, I know if this is back in like the 1800s and you're Charles Darwin, you're like, yeah, the cells are probably like simple things. And you like look at it like under a magnifying glass. You're like, oh yeah, they do look kind of simple. Well, I'm sorry, but that world is gone. It doesn't exist anymore. The world that we now know is a world of incredible complexity at a microscopic level. It's not a simple world, it's a complex world. And that's not even touching really the whole issue of DNA, which is incredibly complex by itself. So I think when we look at even a simple cell, we have to say, here's a good Carl Sagan quote, a living, who's not a Christian, by the way, a living cell is a marvel of detailed and complex architecture. Seen through a microscope, there is an appearance of almost frantic activity. On a deeper level, it is known that molecules are being synthesized at an enormous rate. Almost any enzyme catalyzes the synthesis of more than 100 other molecules per second. In 10 minutes, a sizable fraction of the total mass of a metabolizing bacterial cell has been synthesized. The information content of a simple cell has been estimated at 10 to the 12th bits, comparable to about 100 million pages of the Encyclopedia Britannica. That's one simple cell. We're not talking about a brain cell. We're not talking about a whole bunch of cells working together as an organ to pump your blood day and night without rest for years. We're not talking about the incredible capacity of your eyes to perceive depth and color and all the other things that your complicated brain system processes. We're talking about a simple cell, and it's that complicated. So I think you see something that complicated, you see something that is so apparently well put together, you should infer a designer. In other words, someone of significant enough intelligence to figure it out. But here's the rub. Everything, everyone or everything that is intelligent that we know of in the natural world is made of cells. What stuff is not made of cells? Well, water is not made of cells. Rocks are not made of cells. But everything that's living that we know of in the natural world is made of cells. So who made the cell? You need someone to make the first cell, right? And so obviously I'm arguing that God exists on the basis of that.
So what are other things made of, like just molecules?
Yeah, molecules put together. But the cell is much, you know, it's what gives it life because it has all these little parts that are doing stuff. You know, cells were, like I said, I hit a tree with my car once when I was a younger man. And, you know, the cells just like kind of repaired, you know, sent signals to like the sap to squeeze out and harden up, and then it just repairs. You know, like if you cut yourself, your hand repairs itself. If you cut your tire, what happens? You have to get a new tire, right? Or you repair it, right? But it doesn't repair itself, at least not yet. All right, let's see what else. All right, moving on to argument number 3, which is a DNA argument. I have some handouts for you right here. What? It is about DNA, yeah. It's a DNA argument based on information. This,
Actually,
oh, this might have two.
Are there packets?
Yeah, I couldn't get the printer to automatically staple. I don't know what's going on here at ABC.
Automatic safety machines.
That's what we have in New York, baby. Did you? Oh, you're not in this class.
Not either.
Divide that in half, and then you can have half.
You have an extra packet?
All right.
Everyone's in a
There should be,
size
yeah.
these two.
Make sure Melvin gets one. You got one? All right, so anyhow, this is a DNA argument. It's based not on complexity of how DNA actually functions, but it's based on how DNA stores information. It's something that's totally different than what I just talked about. And I love this little comic, once again, from the Answers book. On one hand, you have a scientist who is working at SETI, Search for Extraterrestrial Intelligence, right? And he's saying, any day now we'll pick up a tiny coded signal, and then we'll know for certain that there's intelligence out there, because coded information does not arise by chance, right? As soon as we get a coded signal, we know there's intelligence out there. And then here's the biologist. The precisely coded information in each cell would fill many books, but we know for certain that no intelligence created life. So there's an obvious inconsistency there between those two approaches in different fields. I'm just going to breeze through this. If you are interested in it, read Perry Marshall's spiel. That's only part of it. His whole thing is actually longer than that, but I'm not here to stress you out. So, no, it's not in there. So this guy, Perry Marshall, is an information specialist. He is somebody who works with like networking and computers and information. And so basically what he argues is that DNA is an encoding, decoding system. In other words, it's a code. DNA is a language. It has letters, it has syntax, it has intent, and it represents something other than itself. And that's always the requirement for something to be an actual code or a language, is that it represents something other than itself, like a map. A map points to a reality beyond itself. You know, I can draw, you know, a map here of, you know, this is like ABC. There's like, it's probably not quite like that. There's like parking spots over here. There's parking spots here, and there's like that barrier, and then parking spots here, right? You can see I'm like just kind of, and like the trees of Avalon or over here, you know, and you see this is not the trees of Avalon. This is a map. This is a representation. These are symbols that are representing another reality, right? And so it is with language. This ink is not universe, right? Universe is a word we use to describe everything that exists in the natural world, right? So that's the way language works. It points to something beyond itself. In other words, it has meaning. So DNA has an alphabet, it has syntax. Combinations of the 4 letters do different things. They cause different things to happen, right? You can take a DNA sequence and you can copy it. You can store it on a computer. You can print it out, right? So that's a characteristic of information. Information is not matter. Information is not energy. It's something that can be stored in matter or stored using energy, right? But it is itself something else other than matter or energy. It's information. And so a DNA, if DNA is a code, if DNA is a language, all examples of languages always come from a mind. But how do you get a mind to design DNA if every mind we know is the result of DNA, right? Every mind we know, whether animal or human, is generated from cells that run on DNA. So how do you get DNA in the first place? You still need it to come from a mind because it is a language. Languages do not arise on their own. What arises on their own is noise, chaos, not language, right? Let's say, for example, you went outside and you saw, I don't know, a bunch of leaves on the ground, arranged, spelling out the word hello. Who in the world would ever say they randomly fell that way? No, you're going to say somebody painstakingly put these leaves and arranged them so that they would spell out hello. That's obvious. You don't even have to think about that. You automatically make the design inference because you know you see language, and nature doesn't generate language by itself, right? It has to come from a mind or come from some sort of system like that. And so that's basically Perry Marshall's argument in a nutshell, is that DNA is a language. Language comes from a mind. There are no languages that do not come from a mind. Therefore, DNA is evidence that a mind exists prior to DNA, i.e. God exists. And so the whole argument for the information argument for DNA hinges on that language comes from a mind. Okay, so that's basically the most important part of that one. All right, on to the last of my 4 arguments for this part. I want to just reiterate some fine-tuning stuff here. And then, and then we could take a break. So I'm just going to rewrite your equation. The force due to gravity is equivalent to the gravitational constant between the mass of object A and the mass of object B divided by the square of their radius.
How do you remember that?
I have it in my notes, but I also took a lot of physics. So anyhow, it's an equation that represents how much force you're going to feel between 2 objects, right? So if object A is the Earth and object B is you, right? How much gravity are you going to feel? Well, the closer you are to the center of the Earth, which would be R in this case, the more gravity you're going to feel. The farther away from the Earth you are, the less gravity you're going to feel. But this letter here, G, is always the same. Doesn't matter if we're talking about 2 planets in outer space or if we're talking about this pen and this pen cap, which do have gravitational attraction to each other. It's just so small that I can't feel it, right? Because their masses are so small. So it's just not much. But the Earth's mass is so huge that it does generate a lot more gravity, right? So anyhow, this G right here is what we call a constant. And there are lots of constants, as Talon shared with us. And this happens to be 6.67 times 10 to the negative 11th Newton meters squared over kilograms squared, whatever. I mean, it's a number. That's the point. It's a number. And that number is the same for anywhere in the universe. And if that number changes, then we start floating off the Earth. Or we get squished down into the Earth, right? And planets start colliding with the sun rather than going around the sun, or they're not held in orbit well enough, and so they float off into outer space and they lose the heat that the sun provides, right? And so that's just one little example of a constant. There are other major constants for governing electromagnetic forces and nuclear forces within molecules, right? And so there are all these different constants. There are lots of them. There are dozens of them. And it's like somebody set each one of those dials in the beginning to be exactly what it needs to be such that we could have life in our universe. And if one of those dials is off just a little bit, life can't exist. All right? And so it's like somebody fixed the numbers underlying the physical equations in the universe. It's like somebody set it up so that we would be able to be here. And this argument, I don't think I have any slides on it, do I? No, I don't think so. This argument is well expressed by, who is this guy? Roger Penrose, who says, the chances of all these constants being exactly what they need to be to support life are 1 in 10 to the 10 to the 123rd power. Okay? 1 in 10 to the 10 to the 123rd power. Actually, I'll say it like that. So that is such a big number. This is Roger Penrose's words. This is an extraordinary figure. One could not possibly even write the number down. It would be 1 followed by 10 to the 123rd successive zeros. even if we were to write a 0 on each separate proton and each separate neutron in the entire universe, and we could throw in all the other particles for good measure, we should fall far short of even writing down the figure needed. That's the chances that the universe would pop into existence with all of these dials, all these constants, exactly the way they currently are. And these are things that don't change. These are things that are not determined by the equations. These are things that are constant no matter what equation or what scenario we're dealing with. So in mathematics, if you come up to something that has a probability of 1 in 10 to the 50th, they call that probability 0. This is so much smaller chance to happen than that, and yet it's common for people to say, oh, I think the universe just sort of popped into being. Right? Don't a lot of people believe that? Let me put it another way. It's more likely that a tornado would pass through a junkyard and assemble a working 747 than that the universe would pop into existence. Far more likely that that would happen. And nobody would ever imagine a tornado actually assembling a working plane if it passed through a junkyard. Right? That's stupid. Who would want to base their life on that kind of improbability? So I think the fine-tuning argument is actually one of the strongest arguments we have, which is why Bill Craig always uses it in his debates. Not just him, but like anybody's argument for God's existence. And it's so science-heavy that it's like so cool that it's on our side. Because it's so awkward. I mean, just imagine there's no God and the universe did. You're trying to like figure out like, well, how did it pop into existence? You're like, well, it's kind of awkward that it's like so perfectly fine-tuned for human life. You know? But for us, it's actually a great evidence for it. So let's go ahead and take a quiz. And if you want to read the Perry-Marshall thing, read it. I'm not assigning it, okay? But it's for your, hold on to it. Maybe down the line you'll be talking to somebody who's studying biology and they're talking about DNA and you're like, I learned somewhere that DNA is information and it's a language and therefore God exists, and I don't remember the in-between steps. He explains all the in-between steps so that it's easy to understand.